Imagine a rock falling. Sounds simple, right? Wrong. What you think you understand about gravity is a naive illusion that crumbles under quantum scrutiny. Classical physics would have you believe this is a straightforward mechanical process. Mass attracts mass, or object accelerates, predictable trajectory. But that's a fairy tale for children playing with toy models. Real physics is far more brutal, far more fascinating. Let's deconstruct what's actually happening when that rock drops. At the quantum level, gravity isn't a force. It's an information transfer mechanism that reveals something profoundly counterintuitive about reality itself. Consider the rock, not as a solid object, but as a collection of quantum information packets, each particle carrying a subtle encoding of space-time itself. When we say the rock falls, we're oversimplifying a complex dance of quantum interactions that makes Newton look like a kindergarten finger painter. Quantum mechanics doesn't just modify our understanding of gravity, it obliterates it. Every particle in that rock is simultaneously communicating its quantum state through an intricate network of probabilistic interactions. Gravity isn't pulling, it's negotiating. It's not a linear process. It's a continuous, real-time recalculation of space-time geometry. Think about acceleration. In classical physics, it's a clean mathematical function. In quantum reality, acceleration becomes a probabilistic conversation between quantum fields. The rock isn't simply moving down, it's constantly being regenerated, its trajectory a fluid negotiation between quantum potentials. How does information propagate through this system? Not through neat, predictable channels, but through quantum entanglement, a mechanism so bizarre that Einstein called it spooky action at a distance. Each particle in the rock is instantaneously correlated with particles light years away, its fall in motion a subtle ripple in a cosmic information network. Gravity, then, isn't a force of attraction. It's an emergent phenomenon arising from information exchanges between quantum systems. When that rock falls, it's not just moving, it's revealing the fundamental fabric of reality, a fabric woven from quantum information threads more intricate than any classical model could comprehend. The classical intuition that a rock simply falls is a comfortable lie we tell ourselves. In reality, we're witnessing a quantum performance where every particle is a performer. Every interaction, a complex choreography of information transfer that makes our mundane understanding look like a child's crayon drawing. Quantum fields don't care about your comfortable assumptions. They operate with a precision and complexity that makes our everyday experience look like a blurry, low-resolution approximation of something far more profound. This isn't poetry. This isn't metaphor. This is the ruthless logic of quantum mechanics dismantling our classical comfort zone, revealing a universe far more interesting than we ever imagined. A rock falling isn't a simple event. It's a quantum drama unfolding at every instant, challenging everything you thought you knew about motion, information, and the very nature of reality. If this challenged how you see reality, follow the channel and tell me what you think. Let's demolish everything you think you know about energy. Not modify, not adjust. Demolish. Energy isn't a property. It's not a thing you can hold or measure with naive classical instruments. Energy is a quantum negotiation so complex that our current models are like trying to describe a symphony using a kazoo. Leonard Susskind, would lean forward, those intense eyes boring into his Stanford students, and declare, "Your understanding of energy is a fairy tale for children who haven't yet learned the language of the universe. Quantum fields don't conserve energy, they negotiate it. Every transfer is a probabilistic conversation happening across dimensions we can barely comprehend. Imagine energy not as a static quantity, but as a breathing entity that morphs, communicates, and transforms with every interaction. Take a simple electron. In classical physics, it's a discrete particle with a defined energy state. Quantum mechanics reveals a far more radical truth, that electron is a probability wave, a quantum probability distribution that exists simultaneously in multiple states. Its energy isn't fixed. It's a continuous negotiation between potential realities. Susskind would often illustrate this using black hole thermodynamics, perhaps his most profound contribution to modern physics. Black holes aren't cosmic garbage disposals. They're ultimate information processors that reveal the deepest secrets of energy transformation. When matter falls into a black hole, it doesn't disappear. It's encoded, transformed, its quantum information preserved through the most extreme transformation in the known universe. The holographic principle, another Susskind breakthrough, suggests that all the information contained in a three-dimensional volume can be represented on a two-dimensional boundary. This isn't metaphor. This is fundamental physics, revealing that our entire three-dimensional experience might be a sophisticated quantum projection where energy isn't conserved in the way we naively imagine, but continuously negotiated across quantum states. Quantum entanglement shatters our classical understanding even further. Particles don't just interact, they become fundamentally linked across vast distances, their energy states correlated in ways that completely defy classical intuition. A change in one particle instantaneously influences another, regardless of spatial separation. Einstein called this spooky action at a distance. But Susskind would argue it's the most natural thing in the universe. We're just too limited to see it. Entropy isn't disorder, it's information. Every energy transfer carries an entropic signature, a quantum fingerprint revealing the underlying dynamics of the system. When Susskind discusses energy, he's not talking about a quantity. He's describing an ongoing dynamic conversation between quantum states that reveals the fundamental architecture of reality. Vacuum fluctuations provide another stunning revelation. Empty space isn't empty. It's a roiling quantum foam where virtual particles are continuously being created and annihilated. Energy emerges from this quantum substrate, a constant dance of potential and manifestation that makes our classical models look like children's stick figure drawings. Consider the uncertainty principle. It's not a limitation, it's a fundamental feature of reality. The more precisely you try to measure a particle's position, the less precisely you can know its momentum. This isn't a measurement problem. This is a fundamental characteristic of quantum systems where energy exists in a state of perpetual negotiation. Relativity and quantum mechanics have been wrestling giants, each revealing fundamental truths about energy that contradict each other. Susskind's work has been instrumental in showing how these seemingly incompatible frameworks might be reconciled through deeper understanding of information and quantum fields. Gauge symmetry, another concept Susskind masterfully explicates, reveals that the laws of physics remain unchanged under certain transformations. But this isn't just mathematical elegance. It's a window into how energy fundamentally operates, revealing symmetries that underpin the most basic interactions in the universe. Decoherence explains how quantum systems transition to classical behavior, but it's not a clean transition. It's a messy, probabilistic process where quantum potentials collapse into seemingly definite states. Energy doesn't simply change. It negotiates its own manifestation. The no-hiding theorem demonstrates that quantum information cannot be completely erased. Every energy transfer leaves a trace, a quantum fingerprint that persists even when we think something has been completely obliterated. This is the universe speaking its fundamental language, a language of conservation, transformation, and infinite complexity. If this challenged how you see reality, follow the channel and tell me what you think. Forget everything you think you know about information. It's not data. It's not bits. It's the fundamental currency of reality itself. When we talk about information, we're not discussing computer algorithms or digital storage. We're unveiling the deepest architectural blueprint of the universe. Leonard Susskind would slam his hand on the podium and declare, "Information is not something we process, it's what processes us." Quantum mechanics reveals a stunning truth. Information is physical. It's not an abstract concept floating above reality. It is reality. Every particle, every interaction, at every moment is an information transfer more complex than any human-made computational system could hope to simulate. The black hole information paradox isn't just a theoretical puzzle. It's a window into the fundamental nature of existence. When matter falls into a black hole, classical physics says information is destroyed. Quantum mechanics says absolutely not. Information is never lost. It's transformed, encoded, redistributed across the quantum landscape in ways that make our classical intuition look like a child's simplistic crayon drawing. Entanglement demonstrates this principle with brutal clarity. Two particles can become so fundamentally linked that their quantum states are inseparable regardless of distance. This isn't metaphor. This is a fundamental mechanism where information transcends spatial limitations, revealing a universe more interconnected than we ever imagined. Consider the no-hiding theorem. Quantum information cannot be completely erased. Every interaction leaves a trace, a quantum fingerprint that persists even when we believe something has been completely obliterated. The universe doesn't forget, it transforms. The holographic principle, perhaps Susskind's most revolutionary contribution, suggests that all the information contained in a three-dimensional volume can be perfectly represented on a two-dimensional boundary. Imagine your entire three-dimensional experience as a sophisticated projection, an intricate quantum hologram where information is constantly negotiating its own existence. Quantum fields aren't passive containers of information. They're active, dynamic systems where information is continuously generated, transformed, and redistributed. Every particle is an information processor more sophisticated than any computer humanity has ever conceived. Decoherence explains how quantum systems transition to classical behavior, but it's not a clean, predictable process. It's a messy, probabilistic negotiation where quantum potentials collapse into seemingly definite states. Information doesn't simply change. It strategically reveals itself. Entropy isn't just disorder. It's a measure of information. Each system carries an entropic signature that reveals its underlying quantum dynamics. When Susskind discusses information, he's describing a living, breathing entity that defines the very structure of reality. Causality itself is a manifestation of information transfer. The limits of information propagation define the boundaries of cause and effect. So our classical understanding of time and space breaks down when we recognize that information doesn't flow like a river. It negotiates its own existence across quantum dimensions. The universe is not a collection of things. It's a continuous information exchange, a quantum conversation happening at scales and speeds that dwarf human comprehension. Every interaction is an information transfer, more nuanced than any language we've ever developed. Gauge symmetry reveals how fundamental interactions maintain their essential character under certain transformations. But this isn't just mathematical elegance. It's a window into how information fundamentally operates, showing symmetries that underpin the most basic interactions in the universe. Vacuum fluctuations provide another stunning revelation. Our empty space isn't empty. It's a roiling quantum foam where virtual particles are continuously being created and annihilated. Information emerges from this quantum substrate, a constant dance of potential and manifestation. Relativity and quantum mechanics have been wrestling giants, each revealing fundamental truths about information that contradict our classical models. Susskind's work has been instrumental in showing how these seemingly incompatible frameworks might be reconciled through a deeper understanding of information and quantum fields. The physical world is an information processing system more sophisticated than any technology we can currently imagine. Reality isn't something that happens to information. Information is what happens. If this challenged how you see reality, follow the channel and tell me what you think. Classical physics is dead. Not dying, dead. Every comfortable assumption you've ever had about reality is about to be surgically dismantled. What we perceive as solid, continuous, predictable is nothing more than a quantum illusion, a probabilistic shadow play projected by incomprehensibly complex information exchanges. Space isn't a container. Time isn't a linear progression. These are emergent phenomena arising from quantum interactions so profound that our everyday experience is equivalent to an amoeba trying to comprehend calculus. Consider space-time itself, not as a backdrop for events, but as a dynamic, fluctuating quantum network where information is constantly negotiating its own existence. Every point in space is a quantum conversation. It's a continuous recalculation of potential states that would make your classical intuition collapse in existential vertigo. The boundaries between observer and observed? Quantum mechanics reveals these as artificial constructs. Measurement isn't a passive recording. It's an active participation that fundamentally alters the system being observed. Your active perception isn't separate from reality. It's a critical component of reality's ongoing construction. Quantum fields don't respect the neat boundaries we imagine. They're interconnected, probabilistic waves of potential that only collapse into seemingly definite states through complex interactions. What appears solid is actually a continuous negotiation between quantum potentials. Entanglement demonstrates this principle with brutal elegance. Gel particles become fundamentally linked across vast distances, their quantum states correlated in ways that completely demolish our classical understanding of locality and causality. Information doesn't just travel, it exists in a state of fundamental interconnectedness that transcends spatial limitations. The holographic principle suggests our three-dimensional experience might be a sophisticated projection encoded on a two-dimensional boundary. Imagine your entire reality as an intricate quantum hologram, where every apparent solidity is a complex information projection more sophisticated than any technology we've conceived. Black holes aren't cosmic garbage disposals. They're ultimate information processors. When matter falls into a black hole, it doesn't disappear. It's transformed, encoded. Well, it's quantum information preserved through the most extreme transformation in the known universe. The event horizon isn't a boundary. It's an information translation layer. Quantum mechanics reveals that uncertainty isn't a limitation. It's a fundamental feature of reality. The more precisely you attempt to measure a system, the more you disturb that very system. This isn't a measurement problem. This is reality's fundamental architecture, speaking its true language. Emergent spacetime suggests that what we perceive as continuous space might arise from more fundamental quantum interactions. Time itself might not be a fundamental quantity, but an emergent phenomenon arising from quantum information exchanges. The gauge symmetries that underpin fundamental interactions reveal a universe far more elegant and interconnected than our classical models could ever imagine. These symmetries aren't mathematical curiosities. They're windows into the fundamental architecture of reality. Vacuum fluctuations demonstrate that empty space is anything but empty. It's a roiling quantum foam where virtual particles are continuously being created and annihilated, a constant dance of potential and manifestation that makes our classical understanding look like a child's simplistic sketch. Quantum decoherence explains how quantum systems transition to classical behavior, but it's not a clean, predictable process. It's a messy, probabilistic negotiation where quantum potentials strategically reveal themselves, challenging every comfortable assumption about predictability and determinism. The no-hiding theorem demonstrates that quantum information cannot be completely erased. Every interaction leaves a trace, a quantum fingerprint that persists even when we believe something has been completely obliterated. The universe doesn't forget, it transforms. We are not observers of reality. We are participants in an ongoing quantum conversation, more complex and fascinating than any narrative we've ever constructed. Reality isn't something that happens to us. We are an emergent manifestation of reality's continuous quantum negotiation. Classical physics is a useful approximation. Quantum mechanics is reality speaking its true language, a language of infinite potential, continuous transformation, and fundamental interconnectedness. If this challenged how you see reality, follow the channel and tell me what you think.